But all right, let's keep going. Let's finalize this testing here, which is a big, massive function. So we'll say function test fulfill random words, picks a winner, resets, and sends money. Let's make this public. Raffle entered and time passed. So this will be our full test. We'll enter, we're in our contract here. We will enter the lottery a couple of times. We will move the time up so that check upkeep returns true. We'll perform upkeep and we'll kick off a request to get a random number. And then we will pretend to be the Chainlink VRF and respond and call fulfill random words. Up here, we're doing something where we are being the Chainlink VRF. The reason that we have to be the Chainlink VRF here is because on our local fake chain, there's no real Chainlink VRF. On a real testnet, this function, of course, wouldn't work because we are not the VRF coordinator v2 mock, right? We can't call fulfill random words. Only the Chainlink node can. So since this is in our kind of fake environment, we can do this. For us, we're going to have to pretend to be the Chainlink node, though, to call fulfill random words in our local test. So let's go ahead and write this out. So let's start with a range. Let's say, let's have uint256 additional entrance equals 5, uint256 starting index equals 1. So since we have this raffle entered and time passed, we already have one person who entered the raffle. So we'll do 5 more and we'll have a starting index of 1 because we're not going to start with index 0. And we'll do 4, uint256 I equals starting index. I is less than starting index plus additional entrance, I plus plus. And now we're going to have a whole bunch of random people enter this raffle. So we'll say address player equals, and we'll create a player. So we can do make ADR player here, or we can do some interesting cast stuff. We can take this uint256I, wrap it as a uint60, and then wrap that as a player. So this would be equivalent to being like address of 1, address of 2, address of 3. And this will generate us an address based off of this number. So each one of these players are going to have a different address. Then we can use the hoax cheat to give our player 1 ether, and we can pretend to be the player. Remember, hoax is one of these cheat codes in here. If we look up hoax, a forge standard cheat code, which sets up a prank. So it's and gives them ether. So it's equivalent to prank plus deal. So we'll hoax the player, and then we'll do raffle dot enter raffle value and trans fee. So now we're entering the raffle, pretending to be a player who actually has some ETH associated with the account. All right, cool. So now we have a whole bunch of players in here. Now what do we need to do? We need to pretend to be Chainlink VRF to get the random number, and then of course, and pick the winner. So we're going to call fulfill random words, pretending to be the Chainlink node here, which takes the request ID and the consumer. So the consumer obviously is going to be the raffle contract. And we just learned how to get the request ID from an event in one of our last tests. We can do it up here. So I'm actually just going to copy this, paste it down here. So now we are going to record the logs. We're going to call perform upkeep, which is going to kick off the request to the Chainlink node. So actually we're going to pretend to be Chainlink in a minute, get the request ID like this. And now we're going to be the Chainlink node now that we've kicked off a request. And we're going to copy this line here, paste this down here. But instead of random request ID, we're going to do the actual request ID. But this takes a uint256. So we're going to cast this bytes32 as a uint256. So just remember this vm.log just counts everything as a bytes32. So that's why we cast it as a uint256. Now that we have the Chainlink VRF actually pretending to be the winner, we can do some asserts. So we could assert the uint256 of the raffle.get raffle state equals 0. It should be back to being open, right? Because if we look in our raffle, we reset the raffle state to being open. Okay, what else should happen? Well, what else do we do in here? We pick a winner. So we should have this recent winner variable should be something. So assert recent winner variable does not equal address 0. We should have a recent winner. And oh, that doesn't actually exist. So let's create a function at the bottom. Function get recent winner. external view, returns address, return s underscore recent winner. Down here, we'll say raffle.get recent winner like this. Okay, so we have a winner. What else do we do in here? We pick a winner, change the state to open. We reset the players array. And do we have a getter there? No. So we have a get players. Let's get the length of the array. So we'll do function get length of players, external view returns uint56, return s underscore players dot length, get length of players. So assert at raffle dot get length of players equals 0, like that. What else do we do? We update the timestamp. Aha. And then do we have a function to get the last timestamp? Nope. Let's create a function there. Function get last timestamp, external view, returns uint256, return s underscore last timestamp, get last timestamp. So we'll say uint256 previous timestamp equals raffle dot get last timestamp. So we should assert previous timestamp is less than raffle dot get timestamp, get last timestamp, because this should be updated. Okay, what else do we do? We should write a test to check this event is emitted. I'm not going to write it, but if you want to write it, please feel free. And then finally, we want to make sure that they actually get sent some money here. So to check how much they won, before we call perform upkeep, so we should say, we should get the uint256 prize, which is going to be equal to the entrance fee plus or times the additional entrance plus 1. So this is going to be the total prize. And then at the bottom, we're going to say assert the recent winner balance should equal their starting balance plus the prize. So starting user balance. What do we hoax down here? How much money? We gave them all 1 ether. Nope, let's change that to starting user balance so that we can have the same thing. So this should be equal to the starting user balance plus the prize. Like that. All right, cool. Let's give this a whirl. Forge test-m, paste that in here. And we get an assertion violated, which is no problem. We're just going to put our -vvv in here and see what we did wrong. Okay, interesting. So it says assertion violated, but we're not exactly sure what the issue was. Oh, and if we scroll up, we can actually see all these logs up here. But we're getting an error, but it's not exactly clear what the error is. And this is actually why it's not great practice to have this many asserts. It's really best practice to have one assert per test. This way, when it breaks, you know exactly what assert is breaking. We can see pretty clearly by commenting out all of these that it's this final assert that's breaking. We're not getting the value of each one of these though, which is a little frustrating. However, if we want to see them though, we can do a little console.log, paste this in here, boop, and console.log, paste the prize in here as well, and see what the difference of these are. So let's go to the top though, make sure we're importing console. We sure are. Okay, go back to the bottom. Let's clear this again. We'll rerun this. This time we'll actually see the console printouts, and we actually see them printed out right here. We can see that these are indeed different. This is the hex of them. If we scroll all the way up to the log section of this, scroll down, we can see that these are different, right? We're getting this number. We're getting two very different numbers for these. So for the recent winner balance, we're getting this. And for the prize, we're getting this, right? So prize, so we should actually not just console out the prize, let's console.log the prize plus the starting user balance, because those are the two that we're actually comparing. Let's rerun the test. And we'll see why these are so different and what their so differences are. I'm going to scroll back up to the logs. And once we get to the logs, we see this is what the difference is. So it looks like the actual balance of the winner is one less than what we were expecting. And this actually makes sense because we didn't calculate the subtracted money that the player sent by entering themselves. So we should actually have this be their current balance is equal to starting user balance plus prize minus the entrance fee, because that's how much they paid to be part of it. Now we'll run this again. And we'll see that we indeed passed because we wrote our test wrong. Amazing. So this is fantastic. We have a test suite, and if we run forge coverage, let's look at what our raffle contract, specifically how much coverage it has. We're looking at 91% of the lines, 92% of statements, 75% of branches, and 80% of functions. This isn't done, but this is much, much better than it was originally. Obviously, we still probably want to test these at some point as well. But this is great. Great job.